Okay, everyone. This week we're going to continue our talk with carrying capacity and resource use. So, looking at per capita review. So, per capita per person would be how many gallons of gasoline is needed in a country with 10 people if the per capita use of gasoline is 2 gallons. Well, we just plug in our little formula here and we have 2 gallons per person times 10 people, which come out to 20 gallon. All right, the first thing we're going to talk about is oil, resource use of oil in both the U.S. and the world. A barrel of oil is equal to 42 U.S. gallons. U.S. oil consumption is about 18 million barrels per day. The world production is about 97 million barrels per day. So what is per capita oil use in the United States? And we look at our little formula right here, and we come out to 0.05 barrels per person. Okay, so what if other countries consumed like the U.S.? Well, what if China consumed like the U.S. did? Well, we take that same formula and we look at China's population, which is about 1.3 billion, and that comes out to almost 75 million barrels of oil needed per day. What about India? 1.2 billion people. That comes out to about 70 million barrels of oil per day. And then if we look at the developing world altogether, we put about 2 billion people, comes out to about 110 million barrels per day. That is if all countries or other countries consumed like the U.S. does. So if we take those numbers and we add those up, the total comes out to about 254 million barrels a day. Again, this is China, India, and the developing world. Right now, world production is 97 million barrels per day. So in order to meet those needs, we would have to increase production 2.6 times. That is, if China, India, and the developing countries all consumed like the U.S. All right. So this is a rough calculation, but based on the number of people now, it is expected to increase. We have talked about this in class, that the human population is projected to increase. And of course, there's going to be issues along with that. With an increasing number of people, there's increasing need, and whenever we have increased oil production, there's potential impacts with habitat fragmentation or breaking down of ecosystems into smaller ecosystems, pollution, leaks from wells or shipping tanks, trains, pipelines. Here is a really good website that you can go to look at some of the worst oil spills in history. In the late 1980s, one that made the news was the Exxon Valdez oil spill off the coast of Alaska. And in recent times, in 2010, we had the BP oil spill in the Gulf, or the Deepwater Horizon oil spill. And again, what issues does this have with climate change? We've talked in class about CO2 emissions, burning of oil and other fossil fuels. And so what overall impact is that going to have? All right, the following 6 slides are of energy use and production in the world. You will not be asked to reproduce specific numbers from these graphs. However, oil consumption in the U.S. and world oil production are fair game for the exam. All right, so here is a graph that kind of talks about oil production, world liquid fuel production and consumption in millions of barrels. Millions of barrels per day. And when we come out here to the end, we're looking at about 5.5 million barrels, or about 100 million barrels per day. Who is producing all of this oil? Well, the number one producer of oil is Russia, followed by Saudi Arabia, and the United States is number 3 in oil production. So here's a graph looking at these 3 countries over time. So if you look at the U.S., that's in blue. You see a big spike around the year 1970, and the general trend has been pretty consistent or slightly decreasing over time. Our oil production has slowed some. If you look at the former Soviet Union, you see large increases in oil production through the 1980s, and then the fall of the Soviet Union in the late 1980s, and then the formation of the country Russia from that, and oil production has taken back off around the year 2000. If you look at Saudi Arabia, they are trending up as well. There was a big dip in the late 80s and early 90s, mostly due to potential war with Iraq and Saddam Hussein, and which ultimately led to the U.S. first Gulf War, Operation Desert Storm. But their production is back up and is trending up. Okay, world fossil fuel consumption. So oil remains number 1 in fossil fuel consumption. Coal is number 2, and natural gas is on the rise as well, but still oil remains number 1. Okay, 36% is petroleum of the U.S. energy consumption in the U.S. in 2015. So of our energy consumed, 36% is for petroleum. 29% natural gas, and 16% is coal. So this petroleum is a big part of fuel, mostly fuel for vehicles. If you come over here and you look at this side of the graph right here, we're talking about biomass. These are things like wood production. Biofuels are things like wheat or switchgrass that is used for fuel. Pretty low overall compared to what we have over here. All right, U.S. primary energy production by major source. Natural gas leads the way at 26, coal at 20, and then crude oil is third. So switching gears a little bit, we'll talk about food consumption. Like energy, conversion of land to agriculture is going to have impacts as well. As there's more people added to the planet, there is going to be more need to be able to feed them. So food production is important, and with that you're going to have impacts in biodiversity as land is going to get cleared and forests are going to be removed, ecosystems are going to be removed. You're going to have issues with pollution where you have a nutrient input. Things like nitrogen and phosphorus get added to aquatic systems. They run off of farmland and they go somewhere. Usually that's into a stream and disrupt the natural flow of that ecosystem. Herbicides and pesticides used on agricultural systems as well, and the impact of soil erosion or even soil degradation. As soil gets used throughout time, it is not as good. All right, this relationship between meat and grain. We're going to talk about that a little bit. Who are the biggest consumers of meat? Well, the country Luxembourg is number 1. Number 2 is the United States. Us here in the U.S., we consume a lot of meat. All right. There are some folks out there who don't eat meat, and that's about 3.4% of the population, or about 8 million people who would identify as vegetarians. All right, there are twice as many women than there are men who identify as vegetarians. A little bit about them. They live both coasts. They are residents mostly of larger cities, and the highest percentage are women working outside the home. About 6% of 18 to 29-year-olds say that they never eat meat, poultry, or fish. And here is a website you can follow the link on and learn a little bit more about that. Okay, so what is the total annual meat consumption in the U.S.? Well, per capita meat consumption in the U.S. is 251 pounds. So if we take this number right here, which is an estimated U.S. population, and we subtract off this number, which is vegetarians and others that don't eat meat, and we times it by 251, our per capita meat consumption, we come out to 38 million tons of meat is consumed in the United States annually. Let me repeat that. 38 million tons of meat is consumed in the U.S. annually. All right, what is the world's total meat production? Well, the world's total meat production is right around 300 million tons. All right, how much meat would the world need if everyone ate meat like the people in the U.S.? Well, we take the per capita meat consumption, which is 251 pounds, and then we times that by a close estimate of the world population, 7.4 billion people, and we come out to this astronomical number, which is 1.86 trillion pounds needed. How many tons is this? Whenever you do the math, you divide by 2,000, that comes out to 928 million tons. So the world meat production is approximately 300 million tons, or only 1/3 of what we would need. So we would need a lot more meat. How is most meat produced in the U.S.? I would like for you to follow the links to each one of these articles and read these. Some really good information out there of how meat is produced, particularly chicken, but we get down here and we talk about pork as well. So these are really good articles that will tell you about production of meat in the U.S. We would all like to think that everything is raised in a perfect farm, in a beautiful environment, and that the animals are all completely healthy and have a good standard of living before they are slaughtered. And we see that in some cases where we have pasture-raised, grass-fed animals like we do down here in the bottom right corner of our screen. But the reality is that is not always the case. What is more often is these things called concentrated animal feeding operations, or what we see up here in the upper left. I would like for you to memorize that term, or that acronym, CAFO. You will see that on the exam. Concentrated animal feeding operations. And these are large compounds where animals are raised to be slaughtered. And oftentimes they are put in very unsanitary conditions, and they live in very, very close proximity to one another. And it's not necessarily life out here on the frontier like you might see or think here. Oftentimes they live in so close that they deplete all their resources very quickly, and this turns into lack of vegetation, and they just basically live in the mud with one another. So kind of eye-opening to see where is our food coming from, and where do these animals live before they are being slaughtered. Okay, so producing meat. So 1 kilogram equals 2.2 pounds. So let's assume it takes 3 kilograms of grain to produce 1 kilogram of meat. How much grain would be needed to produce the amount of meat required to feed the world? The question here is, if we are going to feed the people in the world with meat, how much grain does it take to raise that much meat to feed all of those people? All right, so you take the amount of meat needed and you times it by 3 kilograms to get the grain needed. And the amount of meat needed was this from an earlier slide. We're going to convert the amount of meat needed from pounds to kilograms. Here is our formula there. So our answer comes out to 2.5 billion tons of grain needed to feed all of those animals to produce enough meat for humans. So is there enough grain in the world to do this? Well, our per capita grain production is 300 kilograms, and 300 kilograms per person times the world population comes out to 2.2 billion tons. So we're not there yet at our current grain production. We would not have enough grain to make enough meat to feed all of the people at that rate. But there are issues. Grain production is approximately equal to what is needed, and not all grain goes to feed meat animals. People consume about half of the world's grain directly through things like bread and cakes and tortillas. 17% of the grain is used to make ethanol fuel, and about 35% is used to feed animals. So do you see potential problems with producing the amount of meat needed if everybody ate meat like people in the U.S. do? We would have to vastly increase our grain production to feed the animals to get enough meat production to feed everyone at those rates. All right, current world yearly production of grain is about 2.7 billion tons of grain. 65% is consumed by people and is used to produce fuel, which leaves only about 35% or 0.9 billion tons of grain to feed animals. However, 2.2 billion tons of grain is needed, as we calculated earlier, and grain production will have to increase approximately 2.4 times to reach the number that would be needed. So there is a large mismatch, and the amount of grain produced will need to be increased. Problems with that. Well, how can this be achieved? You would have to increase production in each of the unit areas or each of the farmlands. It would probably require more area in agriculture, affecting biodiversity and habitat loss, meaning that more land is going to have to be cleared for agriculture. It would also require more fertilizers being used and insecticides and pesticides, which brings up a whole nother world of potential issues. The impact on soil and erosion and will increase. Soil degradation. Soil, when it is intensely used year after year, loses its productivity. Marginal lands would be brought into production areas that may not be the best but are going to be needed. And also GMOs. Feeding the world. All right, so how do we get food out to the world? Calculating growing capacity of every country in the world and compare it with food requirements. So today, 66 countries are not able to feed their own people. They have land and water constraints. 16% of people depend on imported food. The projection is in just 30 years, 2050, about 50% of the countries will depend on imported food. This is even more of an issue because those that import food are either petroleum exporters or countries in conflict. So these are countries that already have issues. And so you have to factor in, if they are needing food and they are selling petroleum to get the food that they need, what is going to happen with potential impacts from petroleum, things like climate change? What is going to happen when petroleum may slow, or we move to more renewable energy and the need for petroleum is not going to be there? How are these countries going to be able to get their food that they need when their economy has been based upon petroleum? Then you also have those countries that have problems with distribution of food within their own country, that the wealthy get food and the poor do not. So looking at over the next decade, 600 million new jobs will be needed to be created for new entrants into the workforce. We will need twice as much fresh water. 300 million additional children will need teachers, books, and classrooms. Nearly 839 million workers in developing countries, 27% of global employment, are unable to earn enough to lift themselves and their families above the poverty threshold. So with more people coming into the world, there's going to be more of a demand. Well, we're definitely going to need more resources, and we tend to look at it in terms of food, and we tend to look at it in terms of oil, but also in other things as well. Wood production, concrete, fresh water, electricity. So these are all factors that are going to be taken in as well. Things that are going to be needed for future generations as more people are added to the population. What impact's that going to have on the natural world and ecosystems? Well, we have our forests that are going to be asked for more production. You run into potential problems with deforestation there and utilizing those forest resources. Impacts on fisheries, where fisheries may be overfished to meet food supplies. Impacts on coral reefs. We already know that they are very unique ecosystems. Impacts on water tables, soil erosion and soil degradation. Soil not as good as it was. And CO2 concentrations, something we've talked about a lot in this class with the greenhouse gas effects, adding more CO2 and the negative impacts that it has. Extinction rates. Species are going extinct. So are these just special interest topics? Well, these are things that we need to consider. Sometimes these issues are pushed by politicians and by political affiliations, political groups, and perhaps they are pushed in ways to get votes, but we need to look at the real life implications of all of these and the real life implications of the impact that we have on the environment and what trickle down effects that has onto ecosystems and the demand that it puts on the earth. All right, type of desired world. Well, how can we mitigate problems associated with resource use? Well, renewable energy would be a great way to do that. Efficient urban transport, where we're limiting the amount of vehicles and we have much better systems of getting people around in urban areas. Material recycling. Population stability. And again, something else to think of, are these just special interest topics or are these real life solutions? Okay, do humans impact Earth resources? Well, we've kind of talked about this in the class, and I think the answer is yes. Can we continue life as usual and leave doomsday for the tree huggers? Ecological footprint. Ecological footprint is something that we've talked about in this class earlier, and it's the amount of resources that each human has on the earth, or how much they use on the earth, what impact each human has on the earth, and how much resources they take or how much resources they use. Okay, so tying this all back into carrying capacity. Carrying capacity is the maximum number of organisms of a particular species that can be supported indefinitely in a specific area. We talked about this a little bit last week in class. Whenever you have a population that exceeds carrying capacity, there's not enough resources to go around for this group of people right here, and it causes the population to crash below carrying capacity. These are individuals that die. There's not enough resources for them. Population will continue to grow, and it'll overshoot carrying capacity again, but the ecosystem cannot support it. There's not enough resources to go around, and it causes another die-off, and the system will continue to play itself out. So what is the Earth's carrying capacity? Well, it's really hard to determine an exact number. I don't think we have an exact number, and it really takes into account who is predicting it and what they are looking at. So you might have a physicist and a biologist and an accountant, and they all have different views on what that number would be because they're looking at different factors. It's really hard to make an estimate on the Earth's carrying capacity when you base it on a single resource. So if we look at something like food and try to get an idea of when food runs out, how much food is out there to feed our population, that's really not the best way to do it. It really has to look at multiple resources because we as humans use multiple resources, not just food. So things like wood, fuel, I would put in here electricity as well. Multiple resources are used by humans. So when you're estimating carrying capacity, you have to look at how much of all of those resources are going to be available as well. Possible future population numbers. So this green line is kind of our current trend of where we are now here in about the year 2020. So we're looking at about 7.6 billion people. If we were to continue on our current path, we're looking at around the year 2150, we're up over 25 billion people in the world. Some of these other projections here or predictor models are based on a slower fertility reduction. So if we have slower fertility rates, we could possibly see the population stabilizing around 10 billion people. And if we have a rapid fertility reduction or a TFR of 1.6 or below, then we're going to have the number of deaths exceeding the number of births, and the world population would actually decrease and would stabilize down here around 4 billion people. Again, these are projections, predictor models of what might happen based on different TFRs and based on different birth rates and fertility rates. Okay, something that I want you to do is to go to this YouTube site right here and watch this video that talks about tragedy of the commons. Tragedy of the commons is this concept to where in a shared society when everyone is working together for a common goal, tragedy of the commons occurs when one person goes their own way and does something that hurts the overall goal and hurts everyone else who is working towards that goal. When someone goes their opposite way and does that. So go ahead and look at that video, watch that video, read some of these quotes on tragedy of the commons, get familiar with that term and understanding of that, and think about how that might play into society. Think about how that might play into resource use, food consumption, fossil fuel production, fossil fuel use, and see how that idea may play in as well. Something we can also look at is fertility and income. As a general trend, lower income families tend to have more children and higher income families tend to have less children. And the idea behind that is with fewer children, more resources are put into each child. So they may have look at each individual child and have a little higher quality of living for the lower amounts. So you would have a higher standard of living and higher quality of life. More energy, more attention goes into the fewer children as opposed to having a whole bunch of kids and not as much energy put into that. Okay, so important question here. How many people can the Earth support? Well, it's really difficult to figure that out. And it's really difficult to figure out what global carrying capacity really is. And you really have to look at a whole bunch of different things. Really look at different countries, what technologies they might have, what political institutions might be governing those countries, what political systems they may have, access to food, access to clean water, how much energy is being used, how much resources are being used in all of these different countries. So there's a whole bunch of different things as well. And here is 11 conditional statements. I want you guys to read over and kind of get familiar with that, and familiar with that in an idea of how would you predict global carrying capacity, or how many people might the Earth hold. It's not just a system of how much food is out there or how much space is out there, but you really have to look at governments and what kind of government that they have, the overall well-being of the people, what the birth rates are, the death rates, lots of different factors involved. All right, and your view on carrying capacity. What might be your view on how many people the Earth holds? Might be totally different than someone else's. Might be totally different than someone else's in the same classroom or on the same campus, in the same state, in the same country, or someone in a different country. You know, some people like the natural systems where there's a whole bunch of land out there, and some people are okay with more people around. So you have to really look at some of the domestic and international political institutions, the natural systems, and the distribution of wealth and technology in the world as well. Again, it is our world, it is our choices. Our numbers are high and our resource use is high. Where do we go from here? We can look at projections in the future, we can look at predictor models, but the choices we make now are critical for our future.